All right, let's jump right into this explainer and tackle the digital traffic jam of modern software architecture. If you're an engineer building distributed systems today, you already know the exact chaos I'm talking about. Picture a single client app, like the smartphone right in your pocket, trying to talk directly to, say, 50 different backend microservices, all at the exact same time. That is a massive logistical headache.
This kind of direct-to-client interaction, it results in extreme tight coupling, crippling latency, and an absolute security nightmare for developers. We're talking about chaotic, unmanaged digital traffic just crashing into each other, creating an immediate system gridlock.
So we need a fix. Enter the gateway solution, the ultimate architectural mediator.
Think of the API gateway as a high-tech traffic cop, or better yet, a massive toll plaza sitting directly between the wild west of the internet and your pristine internal microservices. It instantly takes that chaotic, tangled traffic and organizes it into smooth, manageable lanes.
Let's look at its core functions for orchestrating this digital highway.
Instead of forcing the client to navigate the maze on its own, the gateway seamlessly handles three critical jobs: request routing, authentication, and rate limiting. First up is request routing. The gateway evaluates the URL path and HTTP method, and bam, instantly directs the incoming request into the exact right lane for the correct backend service. This completely eliminates client-side confusion.
Next, we have authentication. The gateway steps up as a centralized security shield, validating tokens and enforcing strict access control. It scans incoming data packets and aggressively filters out unauthorized requests way before they can ever touch your vulnerable internal network.
And third, rate limiting. By dropping a hard, physical gate on floods of excessive or flat-out malicious requests, the gateway ensures your back-end operations can easily withstand massive traffic spikes without ever breaking a sweat.
But of course, we need to talk about the single-point trade-off and analyze the architectural risk. Because if we're putting all of this crucial routing and security responsibility onto one single component, what's the ultimate catch? Here's the reality. We are trading the absolute chaos of decentralized connections for highly efficient, centralized management. But that inherently creates a single point of failure, a SPUF. It's a critical bottleneck. Basically, if the gateway goes down, your whole system goes down with it. To mitigate this massive risk, engineers don't just deploy one gateway. They spin up stateless gateway instances sitting right behind load balancers. This setup guarantees high availability, redundancy, and horizontal scaling, seamlessly shifting traffic across multiple nodes so we completely eliminate that single point of failure. This perfectly illustrates why, despite the structural trade-offs, gateways remain the undisputed champions of high-tech digital logistics. As the saying goes, with a microservices architecture, an API gateway becomes almost essential, which really leaves us with one final, undeniable question to chew on. Considering the sheer complexity of today's systems, is any modern distributed application truly scalable without one?